Yeah, so there was two parts of the project. I mean, the first part was we had a large national, smoke taint project with the Victorian department and also La Trobe and us. And of course, when we started to initiate that particular project, we're looking for a lot of smoke tainted wine to actually do some of the remediation treatments with. But interestingly, we just couldn't find any smoke affected wines out there. So we got heavily involved in, I guess, trying to track down some smoke tainted wine. So one of the primary objectives of that first TIF project was to actually artificially smoke a bunch of different grapes on vine and produce some smoke tainted wines that we could then put into looking at some different treatments that we wanted to trial in terms of remediation, so carbon fining, enzyme treatment, and all those sorts of things. The second one was to sort of, I guess, do a bit of a more in-depth study on some of the more promising compounds that we'd actually trialled under a model system out in a more real-world situation. So, interestingly, a lot of the different barrier compounds we tried. So we looked at all the different sort of available horticultural products. A number of which were registered for, I guess, use in the wine grape industry, and others were registered for use in the broader hort industries. And we looked at, the application of those to grapes in a model system. What it showed quite clearly was that most of those actually increased the uptake of smoke taint, especially the oil-based compounds that we have. And so that was a great finding to really understand that some of those particular compounds, including the wetting agents, actually can really significantly influence the uptake of smoke taint compounds from the atmosphere. So what we did under the HIF project was really, take one of those more promising compounds, which was chitosan. So chitosan's, it's registered in the industry, and apply that as a barrier spray. And so what we found by doing the trials work there, we showed consistently, and it lined up, with some of the, I guess, the smaller scale work that we've done as part of that larger collaborative project, that, we saw about a 30% reduction in smoke taint uptake by that, the application of that particular chitosan product. It was really valuable for the larger research project to be able to have access to some Chardonnay, some Pinot, and some Shiraz that we could actually run through and evaluate a whole bunch of other remediation options. So really did a lot of work around carbon in particular. We found out some really cool things about the application of carbon fining to wines in the juice stage, so perhaps more applicable to white wine production. It was really effective at removing some of those glycosides and, looking at, other things with some of the testing with the enzyme treatments as well. So those base wines that we smoked were really important for coming up with some of those recommendations. And like I said, the testing of the barrier compound stuff in the field just gave us, again, like we had a very model lab setup, but actually to be able to apply that in the HIF project in the field gave us some more confidence about the outcome of that particular treatment. So that's been positive. Now, again, 30% reduction is probably not where we're looking at. We want to really see it, much higher than that. So is it a commercial treatment at the moment? No, but again, it's now opened up the door to say, well, what are the other similar type products that we could really trial here around a barrier spray in the future? So, yeah, we saw that project, that a nice little short-term project that really developed, delivered a lot of value to the sector anyway.